We're going to start out by watching the same exact video that you saw yesterday, but you're going to see it again so I can get one more view on my YouTube. Here we go.
All right, distributed property everywhere. We have -3 multiplied to a parentheses. We also have just a regular old negative multiplied to a parentheses. So let's get to it. -3 times +2x is -6x. -3 times -5 is +15. Negative times 6 is -6. Negative times +5x is -5x. Now what we have to do is we have to get rid of one of these x's because there's an x on the left and an x on the right. I'm going to add the 6x from the left because I know by adding a 6x to a -5x right here, I'm going to get just an x. Minus 6 drops down, that's a +x. 15 drops down. In order to get x all by itself, I add 6. 21 equals x, or x equals 21.
All right, so hopefully that brought back a few memories of yesterday. Maybe not. But this is where we left off. We did all those problems, and this is where we left off. Okay? Problem 8. Now, problem 8 is not a fun-looking problem at all. But that's okay. It follows the same exact rules that we're used to, and we're not going to let those decimals ruin our day. First things first, I see a 0.2 multiplied to parentheses. That's distributive property. So if you can do distributive property first, do that first. 0.2 times x is 0.2x. 0.2 times 2 is 0.4. The left side didn't change, so the left side is still 0.1x, and that's going to equal that. Now what I have to do is I have to subtract. I have an x on the left, and I have an x on the right. So I'm going to take my smallest x, which is this guy, and subtract it from both sides. I'm going to subtract 0.1x from both sides. I'm going to cross the guy out on the left. Okay, 0.1x minus 0.1x becomes 0. On the right side, I have 0.2x minus 0.1x, which gives me 0.1x. It's just like saying 2 minus 1. And I still have plus 4. Is x all by itself? Nope. I have a 4 floating around, so I'm going to subtract 4 from both sides. I'm going to subtract 4 from both sides. That gives me -4 equals 0.1x. And that's crossed out. Is x all by itself? No. What's in the way? 0.1's in the way, and it's being multiplied, so I have to divide both sides by 0.1. Divide both sides by 0.1. Cross u out. And wouldn't you know it, -4 divided by 0.1 is actually -40. That's about as hard as they're going to get. So if you're looking at that and you're like, oh man, I don't know, when the numbers were nicer, it seemed to make sense to me, then you're in good shape. And the next problem is actually even easier. See, problem 9 is special. Not because it's distributive property. Distributive property is special. If you take that 3 and multiply it to both of those guys, I have 3x, because 3 times x is 3x, and 3 times 5 is 15. Well, on the left side, I also have 3x plus 15. That's weird. Huh. If I subtract 3x from both sides, that goes away, but that also goes away. And 15 equals 15. What did I do wrong? What did I do wrong? What did I do wrong? Nothing. I did nothing wrong. If your variables disappear, which they did, if your variables disappear and your left side is the exact same as the right side, you don't have one answer. You have an infinite amount of answers. And we're going to say the word infinite solutions. One more time. If your variables disappear and the left side matches up with the right side, it's infinite solutions. If your variables disappear and the left side is exactly the same as the right side, it's infinite solutions, which takes me to more problems. Let's take a look at 10. Let me see. I don't have combining like terms, and I don't have distributive property. I have 3x on the left, and I don't have 3x on the right. I have negative 3x on the right. And whenever we have a variable on the left and a variable on the right, get rid of the smallest one first. The smallest one is negative 3x. So I'm going to add 3x to both sides. Add 3x to both sides. Cross you out. 3x plus 3x is 6x minus 1 equals 1. I have 6x minus 1 on the left side, so I have to add 1. I have to add 1, cross you out. Now I have 6x equals 2. I have 6 in the way, so I'm going to divide everything by 6. And I get the fraction 2 over 6. I know that I can simplify 2 over 6 to 1 over 3. Now, when I first originally looked at this problem, I compared that problem to problem 9. Let me quick go back to problem 9. Problem 9 in blue, and let's just look at the blue part only, so I'll get rid of all this green that's in the way. Let's get rid of all that green that's in the way. All that green. Why is it coming back? Let's get rid of all that green. Look at what I have there in blue. They're the exact same thing. The left side, 3x plus 15, equals 3x plus 15, and that's what let me say infinite solutions. If the left side is the exact same thing as the right side, then I have infinite solutions. Now I go to problem 9 here, there's a 10. Go to problem 10 here, and it looks like I almost have the same exact thing. I mean, I have a 3x and I have a 3x, but the 3x on the left is positive, and the negative 3x on the right is negative. It's a trick. It's a trick. I almost got you. It's a trick. I hope I don't get tricked again. I don't like being fooled. Jennifer Lopez once said, "Don't be fooled by the rocks that I got. I'm still Jenny from the block." And ever since then, I've had a thing about being fooled because I thought she was still Jenny from the block, but no, she's not. She's Jennifer Lopez, and she's doing just fine. Distributed property. I'm going to take 1/3. Remember, when you take 1/3, you divide by 3. So I'm going to take 1/3 of 9, which is 3x. And I'm going to take 1/3 of 3, which means 3 divided by 3, which is 1. And my left side becomes 3x plus 1. Look what I have on the right. 3x plus 1. Now, am I going to get tricked here? 3x plus 1 equals 3x plus 1. Those are exactly the same, which means I have infinite. The moment you notice infinite solutions, the moment you notice that the left side, it is so hard writing on this thing, but the left side is the exact same as the right side. The second you notice that, you can stop what you're doing and say infinite solutions. So if I wanted to subtract 3x, I could have, and then I get 1 equals 1. But again, the moment you notice that the left side is exactly the same as the right side, and 3x plus 1 is exactly the same as 3x plus 1, once you notice that, stop what you're doing and write out infinite solutions. Oh, this guy in his videos, when will he stop?
All right, how many solutions does this equation have? We have double distributed properties, so we got to do this one quick. 3 times 2x, 6x. 3 times -9, -27. Drop down the equals. -4 times 7 is -28. -4 times -1.5x is positive 6x. You have a 6x on the left, you have a 6x on the right. If you subtract 6x, they will both disappear. And when they both disappear, what you have on the left is -27, and what you have on the right is -28. Since these guys don't equal each other, once the variables disappear and you have something that does not make sense, you have no solutions. So the question was, how many solutions does this have? Well, none. No solutions.
Huh. Well, that's weird. That's soup's weird. So when my variables disappeared and I got the same thing, I had infinite solutions. But when my variables disappear and I have different numbers, I get no solutions. I don't know. Let's see what we have here. I have 5.5 minus x on the left and -4.5 minus x on the right. I have a minus x on the left and a minus x on the right. I have the same x's on each side. So if I were to add x to both sides, that would make that disappear, and that would make that disappear. And since my x on the left is exactly the same as my x on the right, the x's disappear. After I do that, I bring down 5.5 equals -4.5. So when my variables disappear, when they're the same number, it's infinite solutions. Well, now my variables disappeared, but they're different numbers. So what does that mean? The opposite. No solutions. That means there's no answer for this problem. None. Every problem that we've done so far had one answer. Then all of a sudden we had infinite answers, which means as many answers as the eyes can see. And now I'm coming up with this crazy problem, and there's no answers. Isn't that life? Sometimes you think you have an answer, and it just turns out you have nothing. Right, gang? Right, teens? Oh, no one's responding in the chat, so I guess you don't know what I'm talking about. You all live bland and boring lives. Distributed property. -3 times 2x is -6x. -3 times -3 is +9. And that's going to equal -6x plus 9. The left side and the right side are exactly the same. And when the left side and the right side are exactly the same, that means it's infinite solution. Wow, those are actually easier than when they're regular problems. These are called special cases. And the special cases are special cases when the left x is the exact same as the right x. And there is no right x. Otherwise, they wouldn't be your x. Am I right, bro? Ex-girlfriends or boyfriends. We don't judge. Without solving, determine whether the equation has one solution or no solutions or infinitely many solutions. Without solving, I could do this. See the z on the left and see the z on the right? They're the same z, which means they'll go away. And when they go away, I'm going to have 1 equals 6. Are they the same number? No. So will it have one solution, no solution, or infinitely many solutions? No solution. And if I were to write out a paragraph, I would say because the z's would go away and 1 does not equal 6. I'd rather have $6 than $1. Similarly, if I quick do this guy over here, distributive property, I would get 6x plus 6 on the right. And what do I have on the left? 6x plus 6. The left guy and the right guy are exactly the same. And when the left guy and the right guy are exactly the same, I'm going to have infinitely many or infinite solutions. Easy. See, you came in today's lesson thinking, this is going to be so hard. Oh, this is going to be so hard. Oh, it's not that bad. It's not that bad. Look at that, we're done. So, where's the error? Let me see. -4 times 2 is -8n. -4 times -3 is 12, so that's good. Oh, look, I have -8n and -8n, so those guys would be the ones that cross out. The heck? That doesn't make sense. The left side and the right side are exactly the same. And it does get 0 equals 0. So the solution isn't n equals 0. If the left side and the right side are exactly the same, it's going to be infinitely many solutions. That's where the problem is. They said the answer was 0, but the answer is actually infinite. That's it.